Ever wondered what really happens when a Java program runs into a memory leak? In this video, I will show you a step-by-step simulation of a Java memory leak, and then we will monitor the JVM's memory usage live in real time. You will see exactly how heap space fills up, how garbage collection responds, and why leaks can bring down even the strongest applications. Whether you are a Java developer, a performance engineer, or just curious about JVM internals, this demo will give you practical insights you can use right away. Let's dive in.
I wrote a really small Java class to reproduce a memory leak and to try to monitor it, just to get a look and feel of how these things work and what's just to get you interested. So what is happening here is I have a string which is called string, which is not so good, and I'm running this loop from 0 to 20, and I am kind of recursively increasing the size of the string. So string is first, this is a string, and then it's going to become 2 times this is a string. Next time it's going to become 4 times. In the next iteration, then it's going to become 16 and so on. I just needed a big object. So I created a this loop to so that the string becomes really big. It's really big actually. In 20 times it will double 20, it will increase to double the size 20 times, which is huge. What then I'm doing is I'm saving this string. I created a list, and I'm saving this string to a list by iterating from 0 to several thousands. We don't even need it because my application runs out of memory like in 50 iterations or something. Um, and it just prints that it's adding the object to the list, and this is the iteration number I. There is a sleep because I pretty much crashed my system when I didn't put a sleep. It's so quick that I can't go and monitor it, so I put a sleep in here. I tried several things, to be honest. You see main, simple main, and then I had final luck with simplest main. Because the problem was whenever I was building this, if it's too much, if it grows too much too quickly, then you don't have the time to monitor. If it grows if it's too much CPU intensive, then my whole laptop was freezing, which is why I had to, like, finally I got success with something which I can monitor by this. So it's not too CPU intensive. It doesn't freeze my laptop. Hopefully it doesn't freeze today because I have just started Elasticsearch and stuff, but I think it's gonna be fine. Okay, I'm just gonna run it. So it's adding object to the list. So far so good. Let's go and quickly start the monitoring. So what I'm gonna show you is JVisualVM. Uh, So inside JDK, you can find it inside the bin folder. A couple of tools like Java Mission Control, jmc.exe, JVisualVM, and JConsole as well, I believe somewhere. The most interesting one, I mean, different cases. So Java Mission Control has a feature called Java flight recording, which is like a black box, records in real time what happened. But I will use JVisualVM, which I, let's say, like, uh, if you have some processes running on your local machine and you start a JVisualVM, it can detect by itself what all is running on the local machine. And you see one process called simplest main, which is this Java application. I think this time I won't be able to monitor because I think it's almost about to fail, so I will restart it. But anyways, it's adding object to the list, and I'm sure it's growing really huge in size right now. Let me kill it because I don't want to wait. So you see it disappeared. Let me start again. Hopefully it will detect. Yeah, hopefully this is the right one. Okay, so I'm connected to this process, Java process, which is simplest main. Uh, in really quick view, you will see that the heap is growing crazy as we are monitoring it. You will also see some ups and downs. The reason being, Java does try to clean up some of the unused objects, and which is why the garbage collection, every time it happens, it cleans up. You see garbage collection activity here. You see that the garbage collector is trying to work actively. It's actually using good CPU. Like if it's using 10% CPU, it's, or I don't know exactly how much, but it is happening, garbage collection. And you see some ups and downs because of the garbage collection. It tries to clean up, but it can't possibly clean up an object that is not freed. So if I'm adding it to the list, that list is still being used. Garbage collector cannot clean up. So you see that it's the size is available is 4 gigabytes roughly, and it is already 2 gigabytes grown. It's now 3, and it will reach 4, and then the test will crash. Um, I don't see lots of huge CPU activity, which I showed you in something in my nmon file. I think the reason is because there is just a few objects, and the garbage collector can just quickly go and check that this object is not clean, is not ready to be cleaned. But in real time, real life, when you have several objects that are occupying memory, I think it will be a bigger task for garbage collector, and you will actually see a huge spike in CPU. You actually see some spikes, but not consistent ones. You see that here it used to be like 10% maximum. Now it's growing up to be um, about 30% here and there, but still not consistent because there is just like 100 objects in the memory that actually probably it's also just a few objects, and garbage collector can quickly go and check what's happening. Doesn't need that much of CPU, but usually the increase in heap is combined with CPU. What happens, these are the threads that were running, not so many because I'm just running the single thread, and the application has already failed, which is why you see the monitoring stopped. uh, you will see out of memory error. If you, I have a JDK, so if I click on it, I will see the description. It says that found when the Java virtual machine cannot allocate an object because it is out of memory. It's simply out of memory. But sometimes, or quite a few times, why I mentioned in the last lecture that you can get different errors or exceptions. Uh, if you use Java, of course, I can tell you, but if you decide to use some other application, some other language, it must have been different. But the reason it is different, could be different, is that sometimes the memory might get filled really slowly, which means you get to 98% of the memory used, and then the remaining 1% will take time. And at that time, if the garbage collector is spending like 98% of the time cleaning up the memory, it's not gonna give you out of memory error. It's gonna give you another error, which is like GC overhead exceeded, which means that garbage collector is spending too much time trying to clean up the memory, and there is not enough luck, and it's using 98% of the time to clean up. So out of memory does not always come as a simple out of memory. It could be a little bit different, but even in that case, the problem is a leak of memory when you have a GC overhead exceeded error. uh, what else? Let me run it one more time to show you one more thing. Uh, there is some more cool features to Java which you can use sometimes when you need them. So if I go ahead and right click here, I can see some options. There is several ways to do the thread dump and heap dumps and application snapshot. I haven't used quite a lot of this application snapshot, but you can always do a thread dump. Um, one good point about thread dump and when it's useful is that when you have freezing application or frozen systems, they're stuck somewhere, the thread dumps are really useful. Heap dumps are obviously useful for analyzing memory. If I do a heap dump right now, it's gonna happen. Yeah. So this is the heap dump that was just saved. Now you can, it's like a snapshot of the memory of the heap, and you can see some interesting stuff. So if I try to find the biggest objects, you can simply click find. Lots of different tools can provide you lots of analysis, like you can probably upload your heap to some interesting tools, websites probably not that safe to upload, but there is so many different ways. But yeah, I mean, it's a better way. Now you can see that the top 20 objects we have is, one is the java.util.arraylist, which is about 1 GB, and java.lang.object. I think it's just a representation of array lists. It shouldn't be different, so it's just the same. If I click on it, then you will see what this object actually contains. Um, if I click on element data, you will see that it has so many elements, and each of the element just contains another string, which is, this is a string, this is a string, and just like this is a string so many times. And you can pretty much start getting the feel that what object is big and what it contains, what could you do to fix this problem. Of course, when you have a real application, it's going to be a little bit more difficult, but I think the process is going to be the same. If you want to look into the heap, this is the classes and instances. So you have several instances of character, string, uh, object, class, method. There should be somewhere. There are quite a lot of strings. I was hoping to see a list, but I don't know. Anyways, just play with it, and you will find lots of stuff. You see when it was taken, what are the total size, total classes, total instances, class loaders, EC roots, number of objects pending. You can go on and on and on and investigate as much as you like, but that's what thread dump is. That's it. I will share this file and you can try to play with it when you get some time, and we will discuss next week.